Mike's question, the channel measures from after the connector. So we have also another missing link when we do the measurement. So always keep it in mind that features of testing are essential to do. So, talking about alien crosstalk, yes, we do have alien crosstalk part of the module today. In Fiber, we have done a major improvements in the Fiber. A whole revolution had come into the Fiber modules. Who knows how many kilometers we could do in single mode on the DTX? Not you. Sorry, Mike. Who knows how many kilometers we can go in DTX? 10 kilometers. We measure on 10 kilometer level according to the limit that was set on the equipment at that time. Today, with the Versa, with the 35 Pro, we can go up to 130 kilometers in single mode. So imagine you have a mega link. We can do the power measurement on it and we can certify it. We can do 12 kilometer multi-mode if you want. We have the Versa is circuit flux compliant, which other testers are not. So we are very sure that this standard compliant in circuit flux testing is going to be rolled out by many cable vendors soon. So you need to be ready, you need to have your equipment ready, because already some of the vendors within this year, they won't accept test of a multi-mode if it is not in circuit flux. So always before you test in the field, contact your cable manufacturer. Ask, do you need in circuit flux testing or you need a regular test? Because you don't want to end up testing thousands of links. And all of a sudden, you get a message, oh, you didn't test in circuit flux, rejected. So make sure, please contact your cable vendor. There are some cable vendors here. You can check with them if they are willing to go with the circuit flux soon on the short term, long term, or they are implementing the circuit flux already. You can always ask these questions. Another improvement, how many seconds was the test in DTX, in Fiber? Sorry? 1 minute? No, that's too long. It was 12 seconds. 12 seconds to test a Fiber link. Now we can do a Fiber link in 3 seconds. It is a lot faster than just 4 times faster than before. Interoperability with the adapters, we use TRCs, which are test reference codes, which I will leave it to Mike in the second session to talk about it. There are some nice questions we have to answer that. And for people who use single fiber testing, one of the limitations of the DTX was we can test only one wavelength on the DTX. Like fiber for the cameras, single core fiber. Now we can test 2 wavelengths on the core, and we can certify that. So we have a lot of improvement into this system. And in that behavior, instead of having a single mode module, multi-mode module, now we have a module that is quad. So you can have one module which can help you test multi-mode and single mode. So no more the need to worry about carrying multi-mode, single mode modules. One module can cater all. So if you want multi-mode alone, yes. If you want single mode alone, yes. If you want the quad, we can always do it. So 35 Pro is the first and only at the moment tester who can do all-in-one power measurement testing. We have developed something, I said, in the beginning of the presentation today. We like to make things simpler. We like simplicity. And simplicity is to have everybody of your technician team do the job by themselves. In Fiber, what is the first thing we do in the Fiber when we go to the site? Who can answer me? The first thing you do when you open your testers in the field, and you open the field, and don't say it. I know you know it. What do you do? We'll say something from the back.
Set reference.
Set reference. Thank you very much. Who does set reference when you go to the field? I don't see any hands. My God. Guys, we need to setting reference, I know some of you are doing it, but setting reference is one of the most important things you need to do in copper and fiber before you start testing. And in fiber is even more critical. To make it even simpler, some people were saying, set reference is complicated, I connect this patch code to that patch code, this connector to that connector, blah. When you hear them talking, you feel like, this is too complicated. This is so simple. And we make it even visual now. So what you need to do is turn on Versa, tell it, okay, I need to do reference, and you see how you need to connect the patch code, even in color modes. So connect the red patch code to there, connect the black patch code to there, and you move on and you move on and you move on. You do the test, you do the reference, you make sure that the reference is good, and when you do the reference, you start doing your test. So, Synergix-Fluke is part of the module. It's, again, we're the only company today that could do Synergix-Fluke in this module inside the TRC, test reference code. The earlier solution of Synergix-Fluke was you have to have like kind of a box, you carry it with you, you have it with the patch code, it's so expensive, it's so difficult to handle, it's so unrobust, I would say. It can break anytime, so it's $1,000 per piece test limits, so it's available now within Fluke Networks family. In OTDR, one of the best features of OTDR today in OptiFiber Pro is the event map. And people who have used our OptiFiber Pro have learned a lot how this OTDR could be fast. We've done a lot of experiences in many projects around the region where we showed that all what you need to do is test in the field, you get a pass, finish. Don't analyze the result, it's already analyzed. It's already analyzed, so we certify. We get to the event map where we show you how the link looked like, so you don't need to look anymore at the traces. If you still want, you can still go there. But I've never touched traces since last year, since we launched OptiFiber Pro. And with the event map, you can see everything. So if a failing link, you can see where it failed. If you see a pass, you see where it's passed. It's 5 seconds. It goes up to 130 kilometers OTDR. And the event dead zone. We're the shortest event dead zone ever today. So we talk about 0.5 meter as the shortest dead zone. Sorry?
And how much distance dead zone
at 0.5 meter.
and how much distance and the pulse rate and these are the specifications.
You have the event dead zone, you have the attenuation dead zone. These are the two core fundamental definitions. From the start, when you have your launch condition, launch cable, you plug it at the connector. From that connector, you have every half a meter, you can detect an event.
If we have 10 kilometers,
Yes.
how
10 kilometers divided by 0.5. 0.5 meters. So 10,000 divided by 0.5, you get to know how many. So there's no limits on the dead zone. It's the whole thing about how much accuracy you can do. This is the first thing. Second is when you're testing a data center environment, in a very complicated environment where you use a short patch code, 1 meter patch code, and you're testing from rack to multiple racks in between. Other OTDR cannot do it. Other OTDR will see the first connector of the patch code and maybe omit 1 or 2 patch codes on the way. With this OTDR, with this OptiFiber Pro, every single connector is detected. You can see the whole link, how it's looking like. It's a lot of activities around it. So 0.5 meter. 0.5 meter is the minimum you can test. So in copper, we are very much known in copper about our diagnostic tools. And we're the only company to diagnose copper testing even. So when you have a failing link in your copper infrastructure, whether it's next or it's return loss or insertion loss or whatever the test would be, we have a way to tell you what is the reason behind it. What is the reason behind it? If it is the next problem, you go to the diagnosis and you enter into the diagnosis to something called HDTX. And from that analysis, what you see in the graph, I can see that my right connector is badly terminated. So I know immediately on the spot that I don't need to re-terminate my 2 connectors. I go to the second connector and I do it. My question is this function available in DTX or not? Is this function available in DTX or not? DTX uses, come on. Available. Don't be shy of it. We had it. That's not an improvement. We had some improvement in the way we do the calculation analysis, yes, in the Versal. But DTX owners, if you have a free of charge diagnostic tool within the DTX, you can use it to figure out where is the problem. Is it a cable pulling issue? Maybe the 5 meter inside the 15 meter or 20 meter link is badly pulled, so the whole cores are badly damaged. How do we know? We could derive. HTX, HTR are the tools available from Fluke networks and only Fluke networks that can tell you how to figure out where is the problem. Diagnostics, again diagnostics. And that's how we do it in OptiFiber Pro, in the event map. When we talk about event map, I don't need to go into traces anymore. I simply visually can tell that my second connector is having a high loss of 1.24 dB at 35 feet from the first connector. You can see it. If you have to do it on the traces, you might spend a lot of time doing it. And why we're so proud of our technology, because we have a solid background. We are a strong company coming from a big standard or big organization called Danaher, which is an $18 billion company. So we have the resources, we have the money to develop, we have all what it takes to bring the latest innovations in the market. We're part of the test and measurement platform of Danaher, where all the different companies you might know here, Hardware Networks, Electronics, Fluke, Biomedical Fluke, Calibration, even BSS is one of the companies that needs to be added here. And we are, as Fluke Networks, we have developed our own technology, and whenever there are areas where we see a technology growing, we go and acquire these companies and these technologies and implement them into our platform. So we are an innovative company, we are trusted, we have the cash it takes to build up, to grow, and focus on what we're doing. So we have a very big focus on what we're doing in network and cable testing. So many companies use us as one of the core cable testing platforms since 1992. So we are quite old in this field. We're not newcomer. We're not simply coming from yesterday. We are a very old company in this field. And we were the very first starters in network and cable testing. So we've done analysis again with people because Versal idea, why it came. It came behind a lot of research and analysis being done in the market. One of the research analysis was, are we in copper? How much you are installing? Are you in copper only? Are you in fiber only? Are you in wireless? Are you in coax? Where are you as a company? And we figured out that many companies do many of these mixes. So you might be doing the same job, doing copper, fiber, coaxial, wireless installation. You need to do network testing, and that's all behind one of the development of the Versal. So fiber and Wi-Fi are now moving in heavily in the enterprise. Going into 40 gigabit today, the only solution for 40 gigabit is fiber. So fiber is growing, fiber is coming more, it's becoming more aggressive than what we need. So things were not possible yesterday, are possible today with Versal. Again, one platform can do all the testing that we need. So it is a trusted tool, it gives you the best support you need, it's very modular, it's standard compliant, it's technically superior, there has a lot of importance and important reports, and it has a project management system. So there are so many things that can tell you, that can show you how versatile the Versal is today. And that's why is the name of the Versal. Versatility. So these things will be discussed later on by Mike. If you are interested in the Versive, what are the paths that we can offer for Versive, and this will be in the afternoon, in the after break session. So, do we have any questions here at the moment? Before I move to my bit of demos in front of you. No questions? Okay. I need a couple of minutes to show you some interesting things when we talk about testing. Let me put the right one in the right place. So, proper. Okay, so let me do it that way. Okay, so what do we have here? We're going to show you how DTX could detect a shield or not, which is normally it. Many installation people by mistake forget to terminate the braid, terminate the drain wire, to do the whole thing of shielded testing. Some companies have defined a design in their connector to force that shield testing, but still, we might find still people missing the shield, missing the connect. Now, what can happen if you don't connect the shield? What can happen? The DTX can tell you you have a wire map failure. Okay? So I will show you what things could be done in DTX to overcome that shield. Which now in the Versive, because of the advanced technology, we could bring lab-level equipment to come and tell you today that the shield is open or not, even if the DTX did not detect it. So, what I'm going to do, a very simple connection to my for people who have seen DTX before, that's the viewer that we have it in Linkware. It's available in Linkware. So what we're going to do is simply test now. What I have as testing is that I need to do a permanent link test. It's a shielded cable, and I do a test. What happens here? Uh-oh. Uh-oh. Wait, I need to... It's a failure. My wire map is good, but my shield is not connected. So this is a normal detection that the shield is not connected. Now, let me do a small trick. This trick is done normally. Why? Because in data centers, all the racks are grounded, are bonded to the ground. So by default, our connectors are bound together to the ground. So what I'm going to do now is I'm going to touch, make the two connectors touch, although the shield is not connected. Make the two connectors touch each other. And look what's happening. My test is going. What I will get? I'm getting a pass. My shield is disconnected. What happened today? Because of the grounding and bonding in the building, connectors will be bonded to the ground. So the field tester could not detect that the shield is really disconnected. If you do a right bonding of your equipment to the ground, that's a reality. That's what we could do. To figure out what's happening was not easily done. And thank you. What we have done in the Versive, we have decided, okay, to get that and to a different understanding, we have done a new innovation in measuring the shield. So, no tester, I don't put the tester. Now, you see the front of my DSX. So what I will do, I will simply make my connection of the shield. So now as if my cable is good, I test my permanent link and I should be able to see my results showing normally. So I see a pass because I have manually connected the shield with my hand. So a link is perfect now. You see the performance, everything is good, it's at 9.3 meters, and the wire length is good. Then what if I disconnect one of the shields? One of the mistakes could be two technicians working on two sides. One technician knows what he's doing very well, and on the other side he forget. While he's cutting the cable, he cut the shield, he cut everything, like moving on. I disconnected the shield. Let me retest now and see what's happening. So one side is disconnected now. I will see immediately a bad lamp information on the screen. So what has happened here? Automatically, the DSX or the Versiv have told me that at the other end, I can see 8.7 meters, so it is at 0 meter from the start of my link. So I know what is the location now of my shield problem. These things were never happening before. They were never ever existing before on DTX, on any other cable tester, and this is purely an innovation in the Versiv. If you have a problem with shielding, Versiv could detect it for you. Now, let's do one thing. What I have done, I connected the two connectors together. I just made them touch each other without any shield. Let's do a test. And see what will happen. Fit in, bad wire map. What DTX could pass by making the two connectors touch each other, Versiv today could not do it. Could not allow it to do it. Because now we do a different analysis on the shield inside the cable. So, looking at this, you can immediately spot the problem. You can immediately tell what is the problem. In DTX, it was not possible because of technology limitation at that time, but today, the impossible became possible in Versiv. So, that's one of the tricks that you can learn on how efficient is the shielded testing for people who install shielded cabling or screen cabling. This is the best way to figure out if the install is good or not. Because we see a lot of arguments today about 6A and even the higher technology, the class F, F8, even the next probably standard of category 8. It's all about shielding. So if you have a worry about shield, today worry is gone. So what I will do now is I will move, since Mike had brought the box, but during the break we will demonstrate how we do troubleshooting on copper link, HTTX, HTTR. So if you have not used it on your DTX, come across this booth here and we will tell you how to analyze failing links in the field and figure out whether it is a cable issue or a connector issue. Now, how much time do we have for Mike? 10 minutes. Okay, so what I will show you is this is a video of 17 minutes, but I will jump in the part of it. This is how we work in operating the DSX or the Versiv. So we need to define a project. You see here we have a list of projects. I need to define a new project. See how simple it is. You go to projects, you click on new projects, and when you define the project, you simply start typing the name of the project. And with this new screen of the Versiv, it's so easy to work with it. If you have a smartphone, and I'm sure all the people here in this room have a smartphone, whether you want to admit or not, you have 1 or 2 or 3 smartphones or smart equipment. So we are coming into a smart board, and that's how we use it. So we define the name, and when we define the name, we see what is inside the project to be defined. We see that we define the operator who works on this project, what kind of standard how many results. So at the moment we see 0 results because we have not set any testing yet on the project. So we set the operator, we simply type the name, and simply when we get the name, we click done, the operator is set, and what after the operator we need to set normally. Or if you remember the DTX, you have to go with the arrows right, left, up, down, put the name, and sometimes you might type the whole name and figure out that you missed a character in the name. And you have to delete, reflex, and then come back. Here, everything is becoming a lot easier. So what we're defining here, after the operators, we define what kind of tests do we need to define, what kind of cable. So fiber type, all the cable manufacturers that are known in the market are available in this. We have a connection with all the cable vendors to include their name, the cable name inside the test. So here we say we has selected as clear curve from Corning, and then is it TIA standard do we need to use, which jumper method, which connector type I need to use, how many connectors, how many splices. All these functions are visual today in one single screen. In DTX, you have to jump from screen to screen, screen to screen. Here, everything in one zone. You can have one look about the whole project in one single shot. Now, we defined the project. Now, we need to define the cable ID. Every project has its own cable ID. So, we define the cable ID, where is the start ID, where is the ending ID in my link. So, we can easily define, and what we're doing here, we're doing a fiber ID. In fiber, how do we define the ID? Sometimes, because we have two ports, so port number 1A, port number 1B, port number 2A, port number 2B, depends on how you want to work on it, depends on the consultant, depends on the standard that is linked to this project. So you can say it's a row 1, link number 10, and ending at B. So when we define it, it tells us, do I need to do what? OTDR, fiber inspector, loss length. So the more I need to do test, the more I can select from this list. So with one list we create, we can tell if we need only to do power measurement or power measurement OTDR and list these IDs inside. So you see now the project is defined. That's where the supervisor in your organization normally or the project manager do, define the project and set them, and you have now the projects available. So the moment I need to change anything in the project, I click on the yellow DC, and then the whole list of projects come back again. So I move to another slide, change project. It's easy. Now, setting reference. When asked what to be done in fiber, Shibu has answered to do reference. And majority of the cable installers forget about it. And that's one of the core important things you need to do the first thing in the morning when you reach to the site. So, when I click on set reference, this is the wizard that we're talking about. Make life simple. Connect the two patch codes that are related to the insert flux. Here we're testing insert flux. So connect the two insert flux models, measure the reference, get the reference value. Once you get the reference value, do click on next. So it shows you what to do. Next, you add additional patch codes. You click next. It tells you to verify that the reference is good. Because it's not about measuring the reference, setting the reference. We need to make sure that the reference is good. So when we do the measurement of the reference, we see that the reference is. So we need to see that the reference has been measured, and once the measurement is done, so you see the measurement and you see that the values are within the limits, 0.08 dB, 0.07, and the recommended limit is 0.15 dB. So we see here that the reference is good, everything is good. Let's move on, and now when you click on next, it tells you that now you are ready to move to the field and start testing your files. So within seconds, the technician could immediately know what to be done, what is to be added, and do the measurement completely. So we are ready now to do the test, and we click on test, and then we move on. So if the codes are not meeting the references, what we will get is a bad. I will move on quickly, so move to the results. So what you see here, if the codes are not good, are dirty, or for a reason they are not a test reference codes, you see that the limit tested here is higher than 0.15 dB. So we have a problem here. What to be done? One of the things will be done, clean the fiber codes. When you clean, you might get a better result. So I'll move straight to the point. Okay. So I move point to the point where we start testing. When we start testing links, you see now everything is visual. You see two links, you click on save, you put the ID you want, and we're ready to go for another test. And when we test, 3 seconds, it comes back, oh, one of the links has having a problem, the other link is good. So you can now visually, with visuals, define which link has a problem. Okay, maybe I want to save the link now, fix it later. Okay, maybe I test a link, it might not be good. Open it, take the passcode, clean the connector, the panel, put it back, test. So maybe a fail could pass because of dust. So we continue testing till we reach to a point where we have a link which requires some later on fix. And that's where it is not within the limits or the knowledge of the technician in the field that, okay, I have a failing link, I need to report that back. We keep on continuing testing until we finish all our project. And again, what we do here is something to improve how fast we can go, is enable autosave. Because I have created my list of IDs in the project. When I click autosave, the project will run a lot faster because the moment I test that link, what is the next ID it will save? Test another link, next ID, it will save automatically rather than doing it manually. And look at how fast today we can do further testing. So the time today to move codes from port to port is longer than doing the test by itself. So now ID number 8, ID number 9, next, ID number 10. So you can see how fast it could be. So when we have done all the links, we finished all the links, we need to go back to the link that has failed. Because we have in one of the links, one had problem. So you see here, out of my results, 21 passing links and 1 had failed. So automatically, let's go to that link and see how we can fix that link. So what you see here is the failing link. You see the code that was related to the link, and then you retest again. When you retest again, the link that was failing had passed because you fixed the problem. Okay. The next link that was tested, because we do always testing on 2 cores, we give it a random ID, and that's what we will do now. We'll give it a random ID, and then that ID can be deleted after we finish that test. So we'll give it as XX, save, boom, and you will see that the project has been completely saved, and you have a passing link. The XX needs to be deleted after that, and we move on, and we see how many links we have. We have 23. One of them should be deleted. So you see how simple it is to test one direction. There are some consultants, some fields which requires bidirectional testing. What does it mean bidirectional testing? Both sides. So with the DTX, we could do it, but even now you'll see how fast even we could do it with the 35 code. Because everything is visual, it's simple. And we made life a lot simple. So what we see here is the bidirectional test. So the test has been set to bidirectional. Let's click on test and see what happens when we click the test. So So when we go and test, we do 3-second test, and automatically the unit will tell you swap the patch codes. So if you forget to swap the patch code, there's a reminder in the unit that please swap the patch codes today. Change that. When you do that, when you click on done, it does the second test. When the test is done, you see that the average result of the testing has been resulted in front of you, have been pushed in front of you. That's a lot of improvement from the way it used to be before. So one after the other, we can continue one after the other. So the concept here, because of the time restriction, this video continues till the end of the 10 links of that we had in the list. So we test 10 times bidirectional testing, and it goes a lot faster. So that's Versa today. It's a lot of improvement from copper testing, fiber testing in Fiber Pro, OTDR testing in Fiber Pro, even in one-touch AD, where we can test LAN and wireless in the field, and we can certify LAN and wireless. We can pass and fail LAN testing. So the idea is Versa. The next is Versa. Today is Versa, and the future is Versa. So the intention is to share with you today the whole logic that we came with the Versa. We want you to become one of the first customers who are aware of the Versa. Versa was launched on 10th in the evening. Today, 12th, we are one of the first launches in the world happening in Dubai. So we are here available today to discuss the product. If you need any clarification, you need to play with the unit. We have 2 units available here, so we can easily explain about it. There are some test platforms you can do your tests. Please come to us, either during the break or even at lunchtime or even after lunchtime. We are here in the room to help you, give you the ideas, and share with you your faith and the development that we have done today. So we have 20 minutes, 25 minutes break? Half an hour break. So let's relax a little bit, some coffee, some snacks. We are here to help. Please, let's come back after half an hour to cater particularly for the fiber topic. And fiber is one of the core topics that we have defined for this event. Thank you.